Okay. Now, call scale number 1, this is very simple. Just want to swap 2 elements. So for example, let's say you have the list and you want to sort the first 2 elements, for example. So list 0, list 1. Oh, this is a non-Python way. So you assign the 10 to list 0. First element take on the second element. So the first element is being replaced by the second element. So the second element now take on the 10, which is the first element. Okay. Then I just need to return this. Okay. So 3, 5, and 5, 3. So this is the traditional way, right, for any other programming language. When we're using Python, we can swap the 2 elements. By assignment, okay. And then after that, I just return the list. Okay, so it does the swap. Okay, now the next one, not only you do the swap, but then you want to sort them. So you don't just anyhow swap. So you say that if the list, the first element, okay, is bigger than the second element, okay, I want to sort it in ascending order. So the first element cannot be bigger than the second element, right? So you do the swap. Okay, if let's say the first element is bigger than second element, then you do the swap. So you build in a condition, and then after that you return the list. Okay, so you realize that 3, 5 will not be sorted. I mean, it's already sorted, so there won't be a swap. 5, 3, because 5 is bigger than 3, so you need to swap, right? And then not only you can compare number, you can also compare string. So between computing and timer string, C and C is the same. O is bigger than H. O is bigger than H, so there must be a swap. So timer string and computing must swap. Okay, if I were to put a print statement in front. Okay, so you realize that all the 3 are being sorted. Okay, if you build in a conditional check, okay, to see whether the first number is bigger than that. Okay, now then we have this thing called the shift. Now, why is there a shift? For example, now you need to know that the first part, this is like your left hand. This is the sorted array. 1, 3, 5, 7, 8. This is the sorted array. Now you have one more element, which is 4. You want to bring it into the sorted array. So the one that you want to bring it into the array is always the last element. Okay, so you need to bring it in. So how are we going to do that? Okay, how are we going to do that? Okay, so let's say I assign an index I, and this I is the length of the list minus 1. Okay, why do I want to have this I? Now this I, if the list in this case is 2, 4, 6, right? 6 minus 1, so that's 5. 5 is actually the index of this last element. 5. Correct? So after you shift these 4 in one spacing, then the 4 now become in the 4th index. So this I will keep decreasing. You understand? The I will keep decreasing. Starting from the last position, it will decrease. I don't want to use -1. I don't want to use -1 because it gets more and more negative, right? Then when it gets more and more negative, it will get out of this first position. I don't want to do that. I want to use a positive number and reduce it until it becomes 0. When it's 0, it reaches the first element. You understand that? So I'm making use of that. So my intention is that my I will be equal to I minus 1 later on. Okay, and I'm going to continue this loop. I'm going to continue this loop while I is more than 0. Okay, I'm going to continue this loop. Got the idea? Okay, so what am I going to do with this? So take for example, I have let me print the list. Let me print the list. Okay, print the list just for fun, and then I have an I position. Okay, and then I reduce it. Okay, let's run. Okay, I didn't do anything to the list, right? But I basically my I changed from 5, 4, 3, 2, 1. So 5, 3 position, right? Index 5. Then it will go to index 4, index. So my 4 will shift. Okay, so the next thing what I want to do is I want to do a comparison. When do I do the swap? I do a swap for it to be right. So I do this swapping. Okay. If it is bigger, I do the swap. If it is bigger, I do the swap. Okay. So now I come back to here. If it's bigger, I do the swap here. Okay. Let me get the indentation correct. If this I element is bigger, or should I say it is smaller, okay, smaller than the previous element, right? If it's smaller, you do the swap. The bigger one will shift the other side, right? So I'll do a swap. Okay, swap between what? The I and the previous element, which is I minus 1. Okay, so I minus 1 swap with I. Okay, so get the algorithm, get the logic right. Okay, I do a swap. Whether I do a swap or I don't do a swap, I still decrease my I, right? Okay, now take a look at this code now. I start off with this index number 5. I compare, I do a swap, right? So it becomes 4 and 8. Now I look at the index number 4, which is this one. I do a comparison. I do a swap again. So it becomes 4, 7, right? Now I look at index number 3. I compare with this, the previous element. I do a swap again, right? But the algorithm carry on and compare 4 and 3, no? Right? Then there's no swap, right? Right now, so this is index number 2. You compare, no swap. Then you will go on the index 1 and do a comparison. Now, my question is that is there a need to carry on to check? No need, right? Because once you find that you are bigger than the previous element, you will therefore be bigger than any other element. You can stop the swapping there already. Okay? So the comparison will stop until when there's no swapping. Even because the rest are all sorted already. Okay? So I'm going to change here. Else. Okay? So if it's smaller, I do the swap. But if it's not smaller, then that means it's at the correct position already, right? In the case of 4 and 3, when you compare 4 and 3, 4 is not smaller than 3. Stop. And once you break, you get out of the loop. Now this I equal to I minus 1, whether you put it over here or you put it outside, it doesn't really matter. Okay, it doesn't really matter. If I put this I equal I plus 1 put outside here, also can. Because once you break out of the loop. Okay, but I choose to put it over there. Okay? Okay, so once I have this, let me run. Now, the moment it reaches 2, means that it is at 0, 1, 2. Here, it stops already. It doesn't go on and check the rest. So my I reach up to 2 and it get out of the loop. So my array is sorted already. Got it? Okay, so this is the first part where you have the left hand sorted, you just plus one more element. Now, these two lines, this line while I bigger than 0, and this condition, if it is smaller, I can actually put them together. I can actually put them together. I can merge these two lines. This condition and this if condition. I can merge them together. So I'm going to do this. Let me copy this code. While this and this. Let me remove off the if. While this and this, I don't need this condition check any. I do a swap. I increase it. No, sorry, I decrease my I. Then it will break when it stops. So you realize that the code becomes very simple now. Can see the two codes? So you just need to compare these two codes and see that they are actually the same. So far, okay? Now let me run this code to make sure that it's working. Just to make sure that there's no typo error. I need to return my list. I forgot to return my list. Okay, I return my list. Break here, and once after I break. Okay. Okay, so I return my list. Okay, I'm going to test a few more times. Now, let's say I try to have a sorted list, 1, 3, 7, 8, and I try to insert a 9. There's no need, right? It's already sorted, right? Correct? But my algorithm must be able to handle this. So this is a case where there's no shifting required. Another case is I'm trying to put in a 1. So this 1 will have to travel all the way to the beginning. So these are the extreme cases. I want to make sure that it works. So you must learn how to design your own test case. Okay, so in both cases it works. 9, don't need to shift, it gets in. And then 1, it gets shifted to the end. Okay, so the last part of the question. Now, this is call skill number 3. Once you have call skill number 3 and number 2, you put them together, you get your algorithm for the whole insertion sort already. Okay, now what I want to do is that I want to iterate through. Okay, I want to look at, okay, this is what I want to look at. I want to look at the first 2 elements, 7 and 1. If 7 and 1, I manage to get it sorted. That's my left hand, right? Then after I get 7 and 1, which is 1, 7, I'm going to have a 3, right? I'm going to bring the 3 inside. Got it? Then after that, I have 7, 1, 3. That means I got 1, 3, 7 already, right? Then I put in a 5. Well, so I want to break it out in this case. So how do I go about doing that? Okay, so this one I call it under iterate. I just want to iterate, so I don't want to do anything. So I say for K in range of starting from 1 to the length of the list. Okay, you need to do a little bit of thinking through. Why do I start with 1? Because I start with the second element. Okay, let's say I print, and then I print the list. I want the whole list, so I want the whole list all the way up to K. So I must put K plus 1. Okay, and then I print that. Then I just return a list. Okay, can. Okay. Whether I return or not, don't return, it doesn't matter. Okay. Now, can you see that? My K will be 1. So 0 to 1, 0 to 2. 0 to 2 means what? 0 and 1 only, right? Because it's not inclusive of K, right? K plus 1. So down here, I better specify and say that K plus 1 not inclusive, right? Okay, K plus 1 not inclusive. So I put k plus 1 here. Understand or not? So now the thing is that all I need to do is to make sure that this one gets sorted. Then the 7 one is sorted already. I include a 3. Then 713 gets sorted, I include a 5. 7135 gets sorted, I include a 8. Understand or not? So how to get this sorted? I make use of the shift. Just how the shift will take care of me to sort the thing, right? Shift will sort this thing, right? And now shift will sort this thing, right? Shift will sort this thing, right? So somehow inside here, the iteration, I must do the shift, right? That's what I'm trying to do. Okay, so I put the two code together. Okay, so I have the shift. Okay, combining the two code. So I have the shift. Put it here. And then I have the iteration. I put it here. Okay. So I try to merge these two codes. Okay, combine the two codes. And I call that insertion sort. Okay? So I need to go through this. Let me copy this inside here. Right? Just that I don't do this. Okay, just that I don't do this. That's kind of I don't do this. Okay? Then I do my sort. But down here, there's a struggle between a K and an I. So the question is, what is the relationship between K and I? So we need to think through a little bit. What's the relationship between K and I? Now, what happens is that our K is that range, right? Is the array, the size of the array. Now, and then when it goes into our sheet, that is the length of the array also. So actually the K and the I, they are actually the same thing. The K and the I is actually the same thing. So what do we do is that we put over here. Now, let me cancel away this. The K and the I is actually the same thing. So the I equal to K. That's all. It is sorted. So if you look at this algorithm itself, there are two parts to it. Okay, it's range. What you are trying to do here? You are trying to iterate through like that. You get an array of 2 elements, 3 elements, 4 elements, 5 elements. That's what you're trying to do. And once you're able to get the array of this, right, then what you do is that you compare. You do a sort. So you take a card from the table, you put in your left hand, then you do a sort. Take a card from the table, you put in your left hand, then you do a sort. Okay, so how many sorts have I done? So let's say I will count the number of sorts. Right? So if I count the number of sorts over here, if right, this is the sorting, right? This is the part where we do the sorting, right? So every time I do this, I increase my number of sorts. That's all. So let me copy this code. Okay, and then put it over here. Now I want to count the number of swaps. So I must have a counter, count equal to 0. Right? Every time I do into a swap, my count plus 1. Okay? And then after that, instead of returning the list, okay, I can, before I return the list, I print my count, let's say. Okay? I print my count or I return my count, that doesn't matter. Okay? So that's what we have. Let's run it. Right? 6 swap. 6 swap. Okay? Now, when you get the swap as 6 swap, you must check through why is it 6 swap. Now, first one you start off with is a 7, 1, right? 7 1 will become 1 7. 7 1 become 1 7. So that's one sort, right? Next, you have the 1 7 and a 3. It will become 1 3 7. Two sort already. Right? So you have 1 3 7. You add a 5 into it. Then it becomes, then this sort here, so it becomes 1 3 5 7. This sort. Then now I have a 1 3 5 7. I add an 8 to it. The 8 don't do a sort. Then the next one is 1 3 5 7 8. Yeah. So down here will be 1 sort, 2 sort, 3 sort, and another 3 sort. 3 plus 3 is 6. Right. Done.